So anyway, it's a real thrill to do this. It's a real thrill to also talk to you about what Austin Energy is trying to do about electric vehicles. We've got a lot of people from my team and our staff salted through the work sessions for the rest of the day. They're the smart people. They're the ones that do all the work. I get the chance to sort of give you a very high-level overview about what's driving our efforts from a business and sort of policy point of view. And this is the idea of vision and leadership that we're trying to instill within the organization, within our community. I'm a firm believer in this sort of vision thing. I've found in my career that if you get the vision right, the uncertainties along the way are easier to negotiate because you can always check back in. And so I like strategic planning where you set clear goals. And I'm going to share with you some of the goals that we're developing for this program. I'm going to move this down just a little bit because I feel like I'm talking pretty loud. Okay, so one of the things that I didn't get a chance to do on this because I'm not really good on some of this PowerPoint stuff is show you some things that you'll hear about later. Our Plug-in Partners program, as well as our Plug-in Everywhere initiative. But Austin and Rachel and Mark Hafner and those folks are going to be talking to you about it later on when they appear in your work sessions. This is all part of it. I just don't have all the logos and cute stuff. So let's get off to the races here and start first with my definition of leadership. As Austin's municipal electric utility, we have a huge service obligation, but we also believe because we are a public entity, we have a leadership obligation. We have to help our community move in a direction that meets the needs of today while also ensuring that future generations will have their needs met as well. And that's the definition of sustainable development, and you're going to hear a little bit more about that in a moment too. So I start first with my definition of the three core tasks of leadership. First, you've got to articulate that vision. As Yogi Berra said, if you don't know where you're going, any road will get you there. You've got to the leaders it's incumbent upon leaders to say, this is what we think the world can look like. Then the hardest part of leadership, of course, is that you have to convene people around that vision, around that agenda, toward accomplishing that vision. And then once they commit, you have to support them in accomplishing those results. So I'm going to talk a little bit about that as we go along. So here's a vision. It hasn't formally been adopted or anything like that, but it's an early start on trying to articulate how electric vehicles integrate with what we do in terms of our electric utility services. And it's the idea that we will integrate our built environment, which is the primary user of electricity today, with the transportation sector, and increasingly power it responsibly by clean, efficient, and increasingly renewable electric energy. That's where we want to go, right? We want them both to be increasingly clean, to be increasingly renewable, to be responsible. And as we do that, because we are a service organization, we must try to provide our customers, and, well, we're going to have to provide our customers with a growing menu of services and options to allow them to maximize their ability to derive value from those services. So there's a vision. It's a model out there. And it fits a little bit with Austin Energy's mission statement, which is as close to a vision statement as we have at Austin Energy. Our mission statement is basically the triple bottom line. I hope a concept which you're familiar with, the idea that as we go forward, if we are to live and develop sustainably, we have to integrate, not balance, integrate the needs of the economy, the environment, and all of society. And so we don't talk about, I say, balancing them, we have to integrate them. We have to solve for all three variables at the same time. What we have to do is develop sustainably and find the common space between those. And that's what's articulated in Austin Energy's mission/vision statement. Our job to deliver clean, affordable, reliable energy and excellent customer service, echoing the same themes that I borrowed on my transportation built environment vision statement. Two things to note here, and I know you all are probably, or most of you all are probably engineers, so I do have to make one point for you, and I'm sorry about this, but for those of you who missed those English classes, there's two things to note about this mission statement. First, there is the there are commas, there's commas and an and. That means the term is in the conjunctive, not the disjunctive. All right? Key point, I know you all knew that. You have to poke a little. Key point, it has to be clean and affordable and reliable. It's not or, it's and. And second, this one's a little more subtle, there is no time constraint in this statement. We have to do it today, and we have to do it tomorrow. Can't give you clean, affordable, reliable electricity today and let things suck tomorrow, right? We can't cripple you in providing electric service to you with costs and burdens that make it unable for you to actually realize a future. You have to do them both. So it's conjunctive both in terms of the list and in terms of time. That's sustainable development requirement. And as we look to today and tomorrow, and as we think about what we must do as an electric service provider, possibly integrating with the transportation sector, anyone thinking about the world out there, and foregoing for a minute any discussions about population, which I'm just not going to have a discussion about, the single most important, unifying, challenging issue, an excellent central concept for us to organize around, is the threat of climate change in our planet, in our nation, in our region, in our cities, in our lives. If you think about it, our fossil fuel thing, our fossil fuel addiction pattern, lifestyle, technology, infrastructure base, whatever you want to call it, positive, negative, just a fact, has got to change because of what's going on a planetary scale. And if we need to do anything, we need to figure out how to move forward to that efficient, reliable, increasingly renewable energy future. And we have to tackle the two biggest sectors, the built environment and the transportation sector, to do so. So it's not just about getting cool cars out there. It's not just about putting cool technology on people's rooftops. It's not just about neat, smart meters. It's about serving an even bigger vision than just our communities of being responsible in the way we live on this planet. And I don't debate the science anymore because I don't think the science is debatable. This is a fact. It's our reality. I saw an article yesterday. With global warming, cholera expected to come back or something, you know. We've got some really big issues to work on. And I take you up to this high level, sort of marching you up from my little vision to the Austin Energy vision to this global issue that we've got, because it's important that we remember as you guys are working on the little things that will build up to those big solutions that we are aiming towards that. And sometimes that can be kind of daunting, but I happened upon a really interesting discussion in a short little article about a year or two ago about climate economics. And I'm not going to make this an economics lecture, but it bears into what I want to talk about and how we're organizing and investing in clean electric transportation in Austin, from a guy named Fred Ackerman. And the issue, he said, with things as big as climate change is that it feels like it's so big we can't grapple with it. And everything we know, all our background education, was not really much aware of climate, because it's a phenomenon we've really only come to understand in the last several decades with any amount of precision. And so we have to do a little bit, as what my old friend Amory Lovin says, rearranging of our mental furniture in order to start grappling with the issues. And he recommends 4 little things. And I love his little article. If you find it, it's just called Climate Economics in 4 Easy Pieces. I love it also because I get to show a picture of my granddaughter and our poodles. Yeah, anyway, she gets into every presentation I ever make. And I'll tell you why. She was born in the year 2000, and when she was born, I realized that she, with modern medical care and good luck, she would probably live to see 100. And so, while I am absolutely certain I will not see the year 2100, remember all the big deal about the millennium, I realized that the minute she was born, I gained a lens on another 100 years. I could actually see 100 years in the future by the things I was doing to and for her. So, the first thing Fred Ackerman tells us about trying to grapple with ideas as big as climate change and the investments we need to make and the activities we need to undertake in order to address a problem of such magnitude is first, that if we apply traditional business discount rates to our evaluation of options and investments, we will undervalue our grandchildren. In other words, a typical business 5 or 6% discount rate makes the future worthless. In other words, on a discounted cash flow basis, the world is not worth saving. Right? It doesn't make any economic sense because the future has so little value on a traditional discounted cash flow basis that you shouldn't make any investments that might pay off 10, 20, or 30 years from now. So you have to break your way out of traditional economic investment calculations. And if you use a discount rate any greater than about 1 or 1.5% in evaluating something as important as climate change investments, and I would argue electric vehicle infrastructure investments or efforts, you are undervaluing the opportunity of the future. Lesson number 1. Lesson number 2. Some insurance is worth buying. The chance that my new home will burn down is very, very small. But the magnitude of the calamity associated with that unlikely event is so great that you cannot carry a mortgage and not have fire insurance today. It just makes sense. Some insurance is worth buying. How much insurance should we buy against the risk of climate change with our investments in things like clean energy infrastructure and electric vehicle infrastructure? Third, and it works around this way, sorry the numbers got cut off, the economists, in many ways sort of the biggest geeks in our entire society, are very proud of their ability to compare the value of all sorts of things. They will tell you about the alternative value of me standing here and you sitting there, or me being out jogging and you sleeping in a little longer. They can value everything, but there are some things that are beyond value. And those things that are beyond value are recognized in the sustainable development movement about 10 or so years ago when we started talking about natural capital, and before that, ecosystem services. Ultimately, if you try to think about what's worth preserving in the future, and you try to equate breathable air with affordable petroleum, you are going to make a mistake. Because breathable air, fertile soils, fishable waters, those natural capital resources, those ecosystem services are beyond all value. And so while we have to approximate in some cases for making these decisions, we should not lose sight of that fact. All our wealth, all our welfare, all our prosperity for us and all future generations ultimately derives from natural capital. And it is the functioning of our natural systems which is at risk in a climate change scenario. It is worth investing in. And then finally, pragmatics. Everything costs something. Everything costs something. The only question is, what do you want to pay? Which cost do you want to bear? At some level, we can invest in electric transportation that connects our city, that connects people to their workplaces and the places that they live their lives. Or we can let people continue to drive around in petroleum vehicles and invest in ambulances, emergency rooms, nebulizers, and asthma treatments for our children. We can make those costs equal all day long. Legislators are doing it right now. But and even if those costs sum up to the same thing, one cost is worth spending on and one is not. So even if we make the numbers equal, we should tilt for the things we want to invest in. That's why I use a picture of a green building, a highly efficient, smart building that provides us lots of benefits for the dollars we must spend. So with those 4 easy little pieces of moving the furniture around, in our brains, you can imagine the mindset that I propose to you should have in your mind when you consider whether you engage yourself in these issues that contribute to solving the problems of global warming, or the future of electric service, or just what do we want to work on today. because they'll all contribute in a positive way. So now let's dig into electric vehicles, because that's what you thought I was going to talk about. First, let me tell you about where we're going as a utility, because how the electric vehicles fits with our plan as a utility is crucial in my discussion. We just recently finally adopted a new integrated resource plan, our resource and climate protection plan. This is a simplified version of it, if you will, a memory palace. I love the mentalists. That's where I heard that last. Make a memory palace if you want to remember things. 35% renewable energy and 20% below 2005 CO2 emission levels by the year 2020. That's our current goal. 35% renewable energy, 20% below 2005 CO2 levels by 2020. We're going to do that with 800 more megawatts of energy efficiency. We've already built one conservation power plant. We're going to add 1,000 megawatts of wind energy. We're going to go to 200 megawatts of solar energy. We're going to have 150 megawatts of biomass energy, and we're going to reduce our effective reliance on our coal plant down to 60% average capacity factor. We're going to learn to live without our coal in case we have to over the next 10 years by introducing a more balanced, efficient, clean portfolio of resources. And we're going to get there building, like I said, on a base of some pretty considerable experience. We've already over 900 megawatts of energy efficiency savings that has saved our customers billions of dollars and allowed us to pay cash for things like our Plug-in Partners initiative to awaken the nation's awareness to the value of, for the manufacturers of cars to invest in new plug-in vehicles. It's saved us on power plants we haven't had to construct. It's allowed us to deploy smart meters to all our customers on a cash basis without having to go in for a rate case. It's allowed us to not have a base rate increase for over 15 years. Pretty good payoff for energy efficiency investments. We're already at 11% renewable energy completely with volunteer support. In other words, entirely by a Choice Green Power program. And why? Because what we offered is the benefits of renewable energy directly to our customers. You see, we can sign a contract for wind power that will be flat on price for 10 years. And they don't care if it came from, burning hay. Getting a contract price for 10 years that's flat is a pretty good deal in business. So 85% of our renewable energy has been sold to business customers because we offer them a flat price with the contract. And that's the power that wind energy affords them. This conservation investment, energy efficiency investment, has resulted in lower bills, 15% lower bills in Austin than the rest of the state. So even if our rates climb 10% higher, which they are not, our customers still pay that less every month. Because, and keep this in mind, of course, electric customers don't pay rates, they pay bills. Rates times bills. We have higher average efficiency. The SEER rating on our air conditioners in Austin is higher than the SEER rating, on average, of air conditioners in San Antonio, as a result of 25 years of rebates, incentives, encouragement. Our system is extremely reliable, and like I said, we've been able to afford to invest in becoming a leader in all this future stuff. Smart grid, plug-in vehicles, green buildings, and other stuff. It actually pays off in numbers. Here's a totally geeked out chart. It doesn't really matter what the numbers are. What I did was I calculated the average bill for the top 17 electric service providers, including the competitive ones, the so-called competitive ones. The average bill based on EIA data in the year 2009. Austin Energy sits here where the arrow is. You could get cheaper bills if you wanted to live in El Paso or the Panhandle. So it is possible. You could have lower bills there if you wanted to live there. Would never disparage those other regions. Warning, Lubbock is still dry. Anyway, and these are the biggest two competitors, TXU and Reliant, where they are providing retail electricity. What does this really mean? Well, what it really means is this, that this monopoly utility with a focus on energy efficiency, clean energy with stable pricing, and hedging strategies and other things offers not just lower bills, but could have offered potential savings. If all the customers of Texas had been Austin Energy customers in 2009, the people of Texas would have had $4.58 billion more in their pocket. So, pretty good deal. Getting to our future involves coordinating a whole lot of things. These are systems problems, I'm going to say that again, including the electric transportation, but we have a bunch of other challenges. In this economy, 1 out of 3 adults in Travis County lives in a household that qualifies for free federal energy weatherization, meaning the household income is at 200% of federal poverty or below. Half the children in Travis County are living in those households. That's the economy. It's a function of the shape of the bell curve and what happens when household earnings stay stagnant or go low. But it's a reality. Social programs are no longer cutesy little add-ons, please contribute $1. We have to figure out how to serve these people as a major component of our customer base, and they are people. We've got to work on things like storage because all that electrical stuff, We've got an initiative on smart grid and a lot of activity in something called Pecan Street. We spun out, in conjunction with the city, Environmental Defense Fund, and the University of Texas, we spun out an independent 501c3 organization, applied and got a $25 million grant, and we are deploying smart grid technology, more importantly, smart grid services and pricings, to learn how to do it in a controlled environment so that we can integrate it back into the grid through the utility itself. My office also manages the building energy code. And just to keep the pressure on my energy efficiency guys, by 2015, we will adopt a zero energy capable home standard, meaning that all new homes and major retrofits must have zero net energy over the year if the home would simply add solar. And given our projections of solar prices by 2020 becoming pretty much vernacular with other generation, that means that we're going to have to work even harder to find our energy efficiency savings as we continue to move forward. We have a citywide climate protection plan that we also have a great deal of involvement with that gets all our departments acting as leaders and showing the way for the rest of our community, including I administer a $20-some million capital budget to deploy solar and energy efficiency on top of into our municipal built infrastructure. And we are working actively to encourage the development of a green economy. I don't try to hire, I try to create businesses. For example, with just 5 years of solar rebates at a $4 million level, we have gone from 4 to 34 solar installers in Austin, because we designed our programs to encourage business growth in that sector. That has led to us being able to win in the first year I was in office, $27 million in federal funding just in my division, plus another $10 million for the Pecan Street project and that $25 million project. So we're playing in a lot of places to try to make this reality come true. We have some challenges. As we increasingly depend on the lowest cost energy resource out there today, wind, well, second to energy efficiency, of course, we come into realities like this. This curve is the curve of demand. And these curves are the curves of wind output. They call that a mismatch, right? We want to use that wind, but we can't move everybody's use of energy to the night. Well, we could if we thought real hard about it, but it might be easier to solve the electrical problem than the human problem. So we've got to deal with that. We've got another problem. When you zoom in on electric vehicles, I call this sort of the Schreiner's cap. This is a sort of typified view of what would happen if you had a plug-in vehicle and you came home every day from work and you plugged it into your wall in the garage and left it there for the night. It would, for the first few hours, try to charge itself, and then it would stop. And your car would add to the most expensive time of cost of generation on the electric grid, and your vehicle would contribute to the highest production of ozone and other local air pollution problems, and it would strain the system. And because you're likely to have bought your car because your neighbor bought one and thought it was really cool, we would have a cluster of you there, And our wires guys would have to be running around looking at whether the transformer could handle the load that the 3 or 4 or 5 of you on your street now are plugging in at 5 o'clock every day. And we would have to be upgrading the circuitry for your benefit, but not for the benefit of everybody else, but just to keep you from crashing the system or tripping the breaker. And that's my scary nightmare scenario. I mean, this is the worst thing in the world. And as the guys who are responsible for safety, reliability, operational security, and fair allocation of infrastructure costs, this scares the, as we say, stuff out of me. So I've got a supply mismatch. I can't run everything on the renewable energy. I've got a charging problem. If I have dumb charging, what do I do? Well, the solutions actually lie in the problems. First thing is, near-term objective, to manage the safety, reliability, security, and for cost allocation reasons, the utility must be able to detect and manage the state and rate of charge. That's your mission. Okay? That's the problem I need worked on. It is not sufficient that I plug my cute electric vehicle into my garage and then sit there on my iPad or my iPhone and go, ooh, look, it's 35% full. That's not meaningful. Reading it off my refrigerator is not helpful. The utility needs to be able to know. And the utility needs to be able to control, work out an arrangement. But for all those other reasons. That's what I need people like you thinking and working on. Communication systems, throughput of data, controls that are reliable, verification protocols, all of that stuff. Because that's what makes these vehicles work today and in the future. How do we solve my little kind of Shriner's cap problem, the one I showed you before? Well, there's a lot of tools in the tool bag. Let me tell you about them. And as I said here in the title, hint, no one is sufficient. There's a lot of silly conversation in the industry rags. Oh, we'll just charge them more. Note, if you're spending $40-some thousand on a volt, you are probably not very price sensitive. If you are spending $105,000 on a Tesla, you are definitely not price sensitive. Charging you $1 a kilowatt hour is not going to keep you off the grid. Pricing alone will not do it. If you have any friends who are neoclassical economists, tell them to stop that. They're wrong. Pricing alone will not do it. It's something to do. It may be fair and reasonable, but it's not enough. Stationary storage. There's a cool idea. We're not quite ready, but I like it as a potentially promising solution. The cars drive the battery costs down with volume and economies of manufacturing scale, making those batteries then affordable to be less used, but able to charge at night and then top the car off when it gets plugged in, and then recharge the stationary storage. I'd love to explore that. Flywheels may be even promising on that kind of use. Charge control, of course, we just talked about that. Solar, because it generates about the same time. Tilt our panels to the west, not so much to the south. Maybe get some late afternoon electricity. There's something there. Solar has to get less expensive. Workplace charging, fascinating idea. Since the main issue that people will face with electric vehicles right away is range anxiety, the fear that their tank is running too low, I could top them off at work. They won't be 2/3 of the way empty or whatever for their commute. They'll only be 1/3 of the way empty when they get home. They might be willing to forego charging until 7 p.m. or 10 p.m. to help me off the peak. The pricing signals might be more effective. And here's something cool. If I have workplace charging, you guys do your job, in a few years when customers are more comfortable having a little less juice in their batteries, or battery performance improves and car weight declines, maybe I can start buying electricity from them in the late afternoon. And if I've already deployed the infrastructure to deal with the range anxiety in the early stages, then maybe I get a twofer. I invest today and reap the rewards tomorrow, and I have a two-way mobile charging network infrastructure already in place. I'm really excited about that idea. And of course, technological improvements, things like hypercars, or what we used to call them at PRMI, power density improvements in batteries. and then all the other complementary strategies that I talked about. So we've got this problem, we've got a suite of options, have to be deployed in some combination to get us to the place. So what do we want to do? Well, we want to charge this transportation fleet with wind energy, right? That solves that power supply, power demand mismatch curve that I showed you. Okay? Then I need to enable the mobile storage resource, things like workplace charging, two-way flow of electricity later on when customers are comfortable with it. Install the infrastructure base at the same time so people are comfortable enough to make their investments in these electric vehicles. All provided by electric service utility that sees all the pricing, reliability, security, and operational issues in front of them at the same time so they can balance all those benefits and risks. And then seamlessly integrated into an infrastructure that includes not just the smarter cars, they're smarter than they are today, but also smart buildings that talk to each other and talk to the cars, and a smart grid that manages it all. Now we're talking about a pretty cool vision for the world. So let me close by giving you some interim conclusions from this very high-level kind of talk. And hopefully that sets the stage for the detail you're going to get into. Leadership does require vision. It really helps if you don't just try to solve the problem in front of you, but that you try to imagine where it could possibly go. Because that'll keep you on course as you butt your head against and over each obstacle you encounter. Leadership is required, but leadership will be rewarded. Our 25-year investment in energy efficiency gave us the headroom to pursue these initiatives. It also gave us the credibility to get that $27 million in federal grants, as well, which includes, by the way, dozens and dozens of electric vehicles and free electric chargers that we'll be deploying, because the federal government knew we were a good place to invest. And so I get to develop this for our ratepayers, our customers, without having to ask for a rate increase for them. These are systems issues. These are systems issues. We've got to solve for multiple variables at the same time. A linear solution will not work, especially given the magnitude of the problems which confront us all over the place. Ironically, municipal electric utilities appear to be the hub for this kind of innovation today. We're in a race with San Antonio to be the coolest utility around because they're regional neighbors and it's a lot of fun. But look at municipal utilities. Ironically, they're the ones that seem to be going after this. Actually, it's not ironic, right? But it's a complicated explanation. And then finally, this is a learning environment. We will make mistakes. Crime would be in not honoring our mistakes and learning. Often go back and reread Kevin Kelly's 9 Rules of God. That closed his book. That wasn't chaos. But anyway, got to honor our mistakes. 9 rules for making something out of nothing. So with that, I thank you for your attention to what is not the technical discussions you probably normally get, but it's all I can handle. And I still get to tell my brother I talked to you. Thank you very much. Well, do we have time for a couple of questions? Okay, I don't think we have mobile mics, but if you'll shout out, I can repeat if people can't hear. No, not yet, but my 2 volts are coming in this month. So we'll be driving them around the office. The charger's just outside my office. Actually, what I do is I bicycle. I have a BMW K1200 that gets 50 miles per gallon and satisfies my middle-aged needs. And, no, not yet. Not yet. But I get paid city salary, too.
I was wondering if you could address 2 things. One is, for how long and how much do you feel that federal spending is necessary to make the migration to electric vehicles viable? And secondly, nobody talks about the value of diversity in energy sources and the total elimination of petroleum and fossil fuel-based energy for the world would move us into an environment where we have a single source that is subject to catastrophic failure across the world.
It would move us into that? Okay. All right, so the first question is, how long do we have to have federal support for transforming to an electric transportation sector? And the answer is less than it will take to make nuclear commercial. We could stop it before we stop We could stop it in much less time than we support coal. We could stop it in much less time than we support even natural gas, which sits in the middle of our choices. We do have to get better than just installing support regimes and then building industries for 100 years or 50 years that run on support regimes. And that's really the key point. When I was at DOE and I ran the R&D portfolio for renewable energy for the country, we built in much shorter timelines for getting to sort of free market commercialization, as if there was such a thing as a truly free market. But here's a reason why I'm hopeful and why I think we can do it, which is even more important. Most of these new technologies that we are talking about represent a fundamental transformation in risk and economics. They do not bear the same level of risk, therefore they are likely to be absorbed by the market faster. You still have to have Price-Anderson protection for liability on nuclear incidents in order to have a nuclear sector. You have to. You can't possibly build a nuclear plant. Heck, no free market economies are really building many nukes. Only socialized economies build them because you have to socialize the costs. I sat on the rate case for Comanche Peak. I have personal experience. But these new technologies are run by economies of manufacturing scale, and therefore they have lower, more diversified risk. We are building cars, not cathedrals. And so I have hope that the market can integrate the results and the benefits of learning much faster, and that there'll be more opportunity for private sector innovation to move in and shift the market, and more encouragement. And it's not really good for government to do that stuff. So I feel pretty good. Specific number, I couldn't tell you. I'm hopeful by the time my granddaughter finishes sort of her formal education. The second question was, what about the risk of reducing diversity? Right now, we are in the increasing diversity range. We need to commercialize solar, commercialize biomass, large and small. We need to commercialize geothermal. We need to do a better job of commercializing energy efficiency. I've run 3 different green building programs in my life, and still it's true there's not a building I have seen that you could not walk into and reduce the energy consumption by 50% with technologies that are available today. That's because later, more technologies will make it possible again. But we still are on the upward scope of increasing the diversity of our resources. In Texas today, we still get the vast majority of our electricity from natural gas, and that kicks us in the you-know-what when gas prices spike, and it's the most volatile priced fuel in the portfolio. We still have a very high reliance on coal in this country, and in some states like Colorado, where I've lived before, the numbers were over 90%. We have a long way to go on increasing diversity, and if we look at both the demand and the supply side of the ledger, I think we still have some improvements. But then we do need to concern ourselves with whether or not we are maintaining a good balance. But good points, both of which. Go ahead, and then I'm going to get you, and then Ron, you can keep me on track.
I'll pass it, I see. For today, do we have anywhere to plug in, or are we just bringing it to the garage? Or
Well, the good news is that the vehicles are coming out, and they're all 110 capable, and they all have a 110 kind of emergency cord, right? And depending on your usage, our former general manager, who's now retired, got his Volt a few weeks ago, told me he's never going to buy a level 2 charger, a 240-volt charger, because his normal around-town commute keeps him off his gas tank. I think he said he's bought 2 gallons of gas in 3 weeks. So he goes at 110 at night. He's perfectly happy. If I could add just some control to him so it doesn't add to the peak, I'm pretty happy with that, too, because he's sleeping from midnight till 6 a.m. now that he's retired. So you can do that. We'll have 100 to 200 level 2 chargers that we'll deploy to make it possible. And because we are a monopoly utility, we'll demand that any public charger accept all vehicles and all customers so that we'll have that network out there. But anywhere you find a 110, you could do emergency charging. This, of course, is only an issue for the all-electric vehicles like the Leaf. The Volt doesn't have that problem. The double-stack battery in a Prius doesn't have that problem because you still have an engine. And I think they're going to be a sizable portion of the market for some time. Here, and then I'm going to go back. Yes, ma'am.
I'm Eramita Miranda. I'm chair of the Education Committee for Metropolitan Los Angeles section. And I thank you so much for a very informative I learned a lot from you today. My question is, could you please comment on your energy storage program?
Right. I'll give you a comment. I'll also give you some. I'll give you a little description. I'll give you an opinion. The big things like utility scale storage, CASE, compressed air energy storage, we do through consortia. We can't possibly carry the weight of that ourselves. So we're in some EPRI consortia, and they're working on that. We also join other consortia like the Coalition for the Commercialization of Energy Technologies, a Texas-based group that is also a smart grid demonstration group, and they're going to be deploying some storage in their Discovery Green demonstration project. And we sort of have people paying attention on the research side to the big stuff or the stuff we can't afford to do ourselves. Do a lot of work on the small scale to ourselves. First of all, we do things like, it doesn't sound quite like storage, but we actually work on solar thermal, and solar hot water. But we're also deploying things like ice bears, those ice machines, which are the 7 kW unit that makes ice at night. We have a district chilling system for our downtown loop that does that in the multi-megawatt scale. We are using some of those we have an incentive program for that in my energy efficiency program. It's thermal storage, is not exactly electrical storage. And otherwise, we're just watching, staying, learning. We've been approached by several people who want to put like megawatt scale batteries at various places. We haven't committed to it. We have a smaller grid than say LA, so it's a little easier for us right now. So that's sort of a quick run of what I can remember. One comment I'll make, just for sort of put a little earworm in and let you guys think about it. I think smart grid kills utility scale storage. So I'm bearish on utility scale storage because I think smart grid kills it. And follow that through your mind and figure out if I'm right and come and tell me someday, but that's sort of my gut feeling right now. I think small scale storage, 25 kW and below, neat complement. And that's about the scale that car batteries kind of go out to, which is why I like that stationary storage option as a complement to electric vehicles. But I'm not an engineer, that's just a sort of a gut feeling from looking at things for 20 years now, something like that. Yes, sir?
Yeah, with the advent or the increasing supply and demand side of DC loads, DC supply with solar storage, LED lighting, the increase, in semiconductors in the home, it would seem to me that there should be initiatives around DC, especially I agree with your statement on utility scale versus local storage. Why are we continuously, if we're serious about efficiency, throwing away 20% of our electricity on conversions?
Yeah.
On both the supply and demand side. And we're going to see that exasperated with storage in vehicles because, it could be a lot more efficient and quick to charge those vehicles from a pure DC storage or DC supply. So could you comment on that as an initiative?
I think you're right. And the good news is that some people are treating this as more than just a rhetorical question. There's a company, Nextech or somebody like that, that's talking about DC networks within the home, maybe even using sort of non-wire carriers for signals and to complement that. I think it's sort of in there. Without getting into a discussion about AC/DC or Edison or whatever we should do, because I'm not capable of doing that. I will say it's incumbent on guys who think about policy to start thinking about sort of the approaches that will encourage that opportunity. One of the things we want to do, I mentioned earlier, by 2015 we want to put in this zero energy capable home standard. That fundamentally changes the way government interacts with builders and the people in the construction industry, because what it says is we can no longer afford to be prescriptive. We can't say your insulation must be R22 and your window must have this fenestration rate and all this sort of stuff, right? We can't, this UV rate or whatever, we can't say those things because we can't possibly prescribe the universe of conditions. So going in that direction leads us to think about things like kWh per square foot per month standards, performance standards. And if you follow any of the standard making stuff like the ISO stuff, and all that, there's a general move in standards to try to go to performance standards when you have diversity of technology options. I think that kind of approach enables us to start being more open to these things. Because if I set a standard for you, 12 kilowatt hours per square foot per month maximum, then go to it, right? And if you get, part of your progress towards a performance standard by integrating a DC circuit for your lights along with an AC circuit for the things that like to run an AC, and it's more cost effective, you'll have an encouragement to pursue that. I don't want to prescribe it, and I certainly don't want to have to order the retrofit of it, but I would like to encourage the environment in which you chase those inefficiencies. Backing it up one more step, what is needed and what I try to do in my group is we treat inefficiency as a resource, right? I want my people pursuing inefficiency wherever they find it and encouraging industry to do the same thing. Hint, that's a really good way to think about low-income customers because their inefficiency is just as valuable as the inefficiency in a McMansion. It's just a little harder to get to. So we just have, and that's the kind of stuff that business innovates around really, really well. Yes,
It occurs to me that with the advances in technology, it may be possible now, rather than building huge mega plants hundreds of miles away and piping electricity, around, that you could have it more distributed. You could have in the neighborhoods, or you could even have houses now. You can have vertical windmills. There's a whole bunch of technology, so houses could generate their own power. Then you've distributed all of this generation, throughout the neighborhood, so the EV plugging in things. What are your thoughts on?
Amory Lovins and me and a few other people wrote a book on this 10 years ago called Small is Profitable, in which we characterized over 200 distinct engineering, technical, financial, and economic benefits associated with right-sized energy resources. Yes, it's absolutely true. In fact, the size of our power plant infrastructure has been shrinking since the 40s anyway. The economy economics and operational considerations have been moving in that direction. I would say add on to that distributed intelligence, and you have one of the fundamental pillars of a transformation of the way we think about energy services, because that allows buildings, I was talking to my friend David earlier on, one of the concepts in sci-fi, and I'm sure some of you geeks read sci-fi, right? Is the singularity. One of my mileposts on the way to the singularity, if there ever is going to be one, which I'm not sure it could be, is when the conversations between buildings outnumber the conversations between people and buildings. And that's what we can enable. And then add in the conversations between buildings and cars and the utility, and now we've distributed intelligence and we've got a much more efficient system. Just to totally geek out. He's going to chase
All
me
right.
off, I'm sorry.
Yeah, we're going to have to bring this to an end
Thank you
because we're
very
beginning
much.
to impose on the next one. So.
Thank you.